Hey everyone, welcome to the Verilog series. In this series, we are going to learn about Verilog from complete basics to advanced. So, this is the first video and it is going to be about introduction to Verilog. First, we'll start with what is Verilog. A Verilog is an hardware description language or HDL. It is used for describing any circuit. As an electronics student, you might have a doubt that what is the difference between programming languages like C or Python versus HDL. Programming languages like C or Python or C++, these are the set of instructions or a program that run on a processor. These programming languages helps us to develop a software or an application or a website that runs on a machine. Whereas in HDL like Verilog, they are used to describe digital circuit. Simply put, it is like designing a circuit. Types of HDL. In HDL, we mainly have four types. Verilog, which is an industry standard hardware description language. VHDL, which is mainly used in defense. System Verilog, which is advanced version of Verilog, and System C. Now that you got an idea, now we'll answer why do we need to use Verilog. Let's say you want to design two input AND gate. We'll simply draw AND symbol and give A and B as input and get Y as output. Try to design an ALU. If you open Google and search ALU circuit, you will see complex circuits, and designing that manually will take so much time and it is lot difficult. Even a small mistake can get the error. So instead of designing manually, we'll describe the circuit using Verilog or any STL. Digital product you see daily like mobiles, laptops and computers. The processor in these devices are designed using an HTL. Companies like Qualcomm, Intel, Nvidia, all of these companies use Verilog or System Verilog to design the chips. Syntax of Verilog. Every Verilog code has mainly three parts: module declaration, input output ports, and the logic. If you are designing any circuit, first you have to declare the name of the circuit. In this example, I declared as my underscore circuit. You can use any name. Next, input output ports. Every digital circuit has some input and output. While writing code, we have to define what is input and output. In this example, I took input A, input B, and output Y. After defining input and output ports, you have to close it with semicolon. Next part is logic. Every digital circuit has some logic. Every Verilog code ends with end module. Comments and whitespace. Similar to C language, in Verilog we have two comment styles. Double slash for single line comment. Slash star to star slash for multi-line comment. And coming to whitespace, Verilog doesn't care about whitespace. You can indent however you want, but please indent consistently. Data types in Verilog. In Verilog, we have two data types, wire and reg. To understand simply, think of wire as actual wire that carries value from one place to another and it has no storage. Reg stores a value, and in future videos I'll explain why we need to use reg and where we use reg and wires. Scalar and vector signals. In Verilog context, scalar means a single bit data. Either it can be 0 or 1, and vector signal is multiple bit data. And we'll represent this multiple bit data inside square brackets. Left side will be the most significant bit and the right side will be the least significant bit. And we'll read it as MSB down to LSB. We'll take an example and understand this. In this example, we took input A, which is a single bit input, and this we can call as scalar signals. And the next one, input 7 down to 0 B, which means this is the input B which has 8-bit data. To represent a 16-bit data, we'll write it as 15 down to 0. Or if you want to represent 32-bit data, we'll write it as 31 down to 0. Number representation in Verilog. First, we'll start with binary. Let's say you want to represent 4-bit data, which is 1001 in Verilog. We'll represent it as 4 apostrophe B1001. The 4 here represent the 4-bit data and B represent a binary number, and 1001 is actual number. Now we'll take a decimal number 255 and represent it in Verilog. First, we'll convert this 255 number into binary. If we convert this, we'll get 8-bit ones. So we'll describe it as 8-bit, a apostrophe, D which is decimal, and 255 which is actual number. Similarly, in octal, if you want to represent any number, let's say 52, first we'll convert it into Verilog, which is going to be a 6-bit. So 6 apostrophe O, which is octal number, and 52, which is the actual number. Coming to hexadecimal, let's take an example FF. First, we'll convert it into binary. If we convert this into binary, we'll get 8-bit ones. So, while describing, we'll write as 8-bit binary, apostrophe, H, which is hexadecimal, and FF, actual number. In the next video, I'll explain about operators and modeling types in Verilog. If you find this video informative and learn something, please do like, share and subscribe. See you in the next one.